Hello everyone, welcome to today's lesson. My name is Sihle Mgaga. Today we'll be looking at sets which forms part of your algebra. So we'll just look at a few sums, of which now we have the first sum, which is a 2x plus 1 under the root minus a 3 equated to 0. Then we will have to take the constant to the other side, then the sign will change to be a positive 3. Then from here we go on to apply the rule, math rule, that says to remove a root you will have to square, then these will cancel, you remain with x, as much as to remove a square you will have to root, then these they cancel, you remain with x. So most of the sums when dealing with sets you'll use this rule. Let's go back to our sum, which is 2x plus 1 under the root, which is equal to a 3. Now we are to remove this root. To remove a root, we just said we'll have to square. So 2x plus 1 squared. Then remember, what you do on the left you must do on the right, which is a 3. I'll have to square the 3 as well. Then these will cancel. Then I remain with 2x plus 1 being equals to a 3 times 3. From here I go on to find a 2x plus 1 equals to a 9. Then I'm solving for x, so I must make x subject of the formula. From here I go on to say 2x is equals to a 9. Take the 1 to the other side, the sign changes. Then I remain with the 2x is equals to an 8. Then I divide by 2, so I may remain with x. What I do on the left I must do on the right. So the 2 cancel 2, I remain with x, and 8 divided by 2 I get a 4, of which means my x is a 4. Then we are done with this sum. Now we are on our second sum, which is root of x minus 1 under the root being equals to a 2. So we still go on to use the rule that says to remove a root you'll have to square. These will cancel that. Then you remain with x, as much as to remove a square you will have to root. They cancel, I remain with an x. So even on our sum we have to remove this root because we are solving for x. So we first have to remove this root by squaring both sides. We square both sides. Since what I do on the left I must do on the right, so I had to square the 2 as well. Then these will cancel. What remains is the root of x minus 1 being equated to a 2 times 2. Then I get the root of x minus 1 is equals to a 4. Then we go on to take the 1 to the other side, which is a 4. The one which have to change the sign is a plus 1. Then we get root of x equals to a 5. From here, I'm solving for x, so I have to remove this root as well by squaring both sides. What I do on the left, I'll have to do on the right. 5 squared. These will cancel. I remain with x is equals to 5 times 5, which that will give me a 25. So my x for this sum, x is 25. Yeah, we are done with this sum. Equals to root of 32 plus the root of 18. So when dealing with such sums, you must bear in mind that it's not always the case where you will find a perfect square. And the moment you find a number that is not a perfect square under the root, the rule is you must find two numbers that will multiply and they must give you 32. But one of those numbers must be a perfect square. Only one. You can't use both numbers being perfect squares. So for 32, I must find two numbers that will multiply and they'll give me a 32. One of those numbers must be a perfect square. So I'm using 16 times 2 plus, I do the same with 18. I need two numbers that will multiply. They must give me an 18. One of those numbers must be a perfect square. So I go for a 9 times a 2. Then from here, I continue to say root of 16 times the root of 2, which this is the same thing, plus a root of 9 times a root of 2. Then from here, we continue to say the root of 16 is a 4. So it's going to be a 4 times the root of 2 plus the root of 9 is a 3 times the root of 2. Then from here, I go on to treat these as my like terms. This is a 4 root of 2 plus a 3 root of 2, meaning that these are like terms. So a 4 root of 2 plus a 3 root of 2, they give me a 7 root of 2. Then from here, I'll have to remove the root by squaring. Then what I do on the left, I'll have to do on the right. So they'll cancel out. Then I remain with x. Then here, I'll have the same bracket twice. Which is, I go on to multiply 7 times 7. I get a 49. Root of 2 times the root of 2. I get a 2. Then x is equals to a 98. So this is my x value for this sum in particular. So now you can go on to check if your answer is correct by substituting your x under the root here. Then also the answer you'll get must be the same as the answer that you'll get when you add these root of 32 plus root of 18. So if you get the same answer, then you know for sure that your x value is correct. Our fourth sum. So For this sum, we have x with exponent 1 over 2 is equals to a root of 45 minus a root of 16 plus 4. So here, we still have some things to fix first before we go on to solve. So remember that a root of x is the same as x, you take this 1, you take this, so I wrote the same thing. A root of x is the same as x to the exponent 1 over 2, as much as a cube root of x squared is the same as a cube root of x squared is the same as x to the exponent 2 over 3. Therefore, we go back to our sum. We are saying that x is to the exponent 1 over 2, of which this is the same as root of x. Then we go on to fix that as well, which is our 16 plus 4, which gives us a 20. Then from here, we can go on to solve what's on the right, which is a 45. A 45 is not a perfect square, so I need two numbers that I'll multiply, and they must give me a 45. Then one of those numbers must be a perfect square. So I'll use a 9 times 5 minus, same goes for a 20 is not a perfect square, so I'll need two numbers that I'll multiply, and they must give me a 20. One of those numbers must be a perfect square, so I'll go for a 4 times 5. So from here, I go on to separate these. Root of 9 times a root of 5 minus root of 4 times a root of 5. A root of 9, it's a 3 times the root of 5, so it's a 3 root of 5 minus a root of 4, it's a 2 times a root of 5. Then I am seeing that I have like terms. 3 root of 5 minus 2 root of 5. These are like terms. It's a 3 minus a 2. I get a 1, which you can just write that as your root of 5. 1 root of 5 with an invisible 1. Then from here, I can then go on to remove the root by squaring. Then what I do on the left, I'll have to do on the right. Then from here, I know these will cancel. I remain with x. Then this is the same bracket twice. So I'll have a root of 5 times the root of 5, of which that will give me root of 5 times the root of 5. My answer will be a 5. So we are done with this sum. The x value for this sum is 5. We are now on our fifth sum. So the sum we have, it's a root of x, open bracket, root of x minus 1, close the bracket, equals to a 4 minus the root of x. Okay, so for this sum, we will have to firstly deal with the brackets because of the BODMAS rule. So root of x times root of x, we are going to get an x. Then root of x times a negative 1, we get a negative root of x equals to a 4 minus root of x. Yeah, then from here, we continue to say we take our x to the other side. We can still take the root of x to the other side. You will decide. So in this instance, let's take the root of x to the other side. So I take this x equals to a 4 minus the root of x. I take this root of x to the other side, I'll get a plus root of x. So these two will cancel out. Negative root of x plus a root of x, they are gone. So what remains is actually x is equals to a 4. So that's my answer. The sum we are having is a 3 plus x minus 1 under the root is equals to x. So we'll take 3 to the other side, then we'll remain with x minus 1, x, take this 3 to the other side, it's gonna change the sign, minus 3. Then from here, we'll have to remove the root by squaring. It's x minus 1 squared is equals to, what you do on the left, you must do on the right, x minus 3 squared. These will cancel out. What remains, it's x minus 1 equals to, this means the same bracket twice. I'll have an x minus 3, x minus 3, then x minus 1 equals to, then we'll have to do a FOIL method, which will be x and x, you get an x squared, x and negative 3, you get a negative 3x, negative 3 times x, still get a negative 3x, then 3 times 3, you get a plus 9. Then from here, collect the like terms, which is negative 3x minus 3x. So we're going to have an x squared. This will give us a minus 6x plus a 9. Then x minus 1. We are still gonna take these to the other side so that our equation can be equated to 0. So we take these to the other side. We remain with, it's x squared minus 6x plus a 9. I take this to the other side. It's gonna give us a plus 1. I take this x to the other side. It's gonna give us a minus x. Then what remains here is a 0. So now, just to put this in a standard form, we'll have an x squared, then minus 6x, like terms, minus 6x and minus x. Then I get an x squared. These two will give me a minus 7x, as much as 9 and 1 will give me a 10 equated to 0. Then I can just shift this to be an x squared minus 7x plus a 10 equated to 0. Then from here, I'll have to find the factors of which is my x and x. Two numbers, when I multiply, they must give me a 10. When I add them, they must give me a negative 7. So I go for a 5 and a 2. Then from here, a plus means that my signs are to be the same, going to that product rule of a negative times a negative, giving us a positive is a positive times a positive, still giving us a positive, and a negative times a positive, giving us a negative. So a positive, you forever get it only if your signs are the same. Your signs, you multiply the same sign, you forever get a positive. So in this instance, our C has a positive, meaning that my signs are to be the same in bracket. But which sign is that? It's a sign of the middle term. My middle term is having a negative. So my signs are the same, but the sign of the middle term, which is a negative. Then from here, we go on to say x minus 5 is equals to a 0, or x minus 2 is equals to a 0. Then x is equals to, take the 5 to the other side, the sign will change, it's a plus 5, x is 5. Then I do the same this side, x, I take the 2 to the other side, we're gonna get an x, it's a 2. Now that we have the x values, x is 5, x is 2, we now can do a test just to check if both these x values qualify. So we can take your x is 5 and place it here, substitute it here. Then what you'll get that your left hand side is a 5. Then you put the very same x value this side, you'll get a 5. Therefore, both these sides will balance. We'll have a 5 and we'll have a 5 this side as well. Then now, since 5 qualifies, we must go on now to check a 2. We take our 2, substitute here where there is x. What we'll get a 4. Then we take the very same 2 we put here, we'll get a 2. So now my sides are not balancing. I'll have a 4 this side, and this side I'll have a 2. Therefore, you have to conclude that x is not equals to 2. Reason why? When I substitute 2, my side won't balance. But if I substitute 5, my side balances. Therefore, the answer for this is only x is equals to 5. But x is not equals to a 2. And we'll get a mark for this conclusion. If you just leave it here, you won't get this mark. So, the sum is x minus 3 root of x minus a 10 equals to a 0. So for this one, let's take these. Okay, x is 3 root of x equals to, we take our 10 to the other side, it becomes positive. Then next up, we must take this x to the other side. So on our left, we remain with 3, negative 3 root of x being equals to a 10 minus x. So now that we have left our negative 3 root of x on our left side, we have now to remove the root. And to remove a root, we square. So you can just square what's on the left. Then what you do on the left, you'll have to do on the right. You have a 10 minus x squared as well. Then this side, we are going to have, let's go for the same bracket twice, which is a negative 3 root of x, same bracket twice, negative 3 root of x is equals to same bracket twice this side as well, which is our 10 minus x, 10 minus x. Then from here, we go on to multiply negative 3 times negative 3, we get a 9, positive 9. Root of x times root of x, we get an x. Then we go on to solve what's on the right, which is 10 times 10, we get 100. 10 times negative x, we get a negative 10x. Negative x times 10, we still get a negative 10x. Then we go on to multiply negative 10, negative x times negative x. We then get a plus x squared. Then these two are like terms, negative 10x minus 10x. These are like terms. So I'll go on to say x squared. These two, they give me a negative 20x plus 100. Then this side, I have this 9x. Then from here, I'll have to take the 9x to the right and the sign will change. When I take my 9x to the right, what remains this side is a 0. So I'll have an x squared minus 20x plus 100. Take the 9x to the other side, it changes the sign, negative 9x. Then from here, we go on to say x squared minus 20, negative 20x minus 9x, we get a negative 29x plus 100 equated to a 0. Then I go on to just write it in a standard form, negative 29x plus 100, then equate that to a 0. Then from here, we have to factorize this equation where we are to say, are there numbers that you can multiply? They give you 100. When you add them, they give you a 29. Then if you struggle with factors, you can go on to do your calculation using the quadratic formula, of which that will follow as x is equals to a minus b plus or minus b squared minus 4ac. Then now, if you choose to use the quadratic formula, this is the equation you will use. But now, we won't use the quadratic formula. It could also work, but it is gonna take longer than you just using the factors. So we are gonna solve this equation using the factors, but this is a quadratic formula you could use to find your x values if you're struggling to find the factors. So now we're gonna use the factors, meaning that I'll erase this. Then we go for the factors, of which our factors will be x and x, then 25 and 4. Since it's a plus, it means my signs are the same. And which sign is that? It's sign of the middle term. So I'll use a negative and a negative. Then I equate these to 0. X minus 25 is equals to a 0. Or x minus 4 is equals to a 0. Then x is equals to, take 25 to the other side, the sign changes. X is equals to a 25. Then also my X, take the 4 to the other side, my X will be a 4. Then after, I'm gonna use my calculator to check if both these values qualify to be used as my X values. Then I'll take my 25, substitute it where I see X, then I must get a 0. If I get a 0, then 25 qualifies. Same goes, I'm gonna take my 4, substitute on my equation, I must still get a 0. So now, you can also do it. You start to substitute your 25 where you see X, which is a minus 3 root of 25, then it's a minus 10. We indeed get a 0. If we substitute 25 where there is X, we do get a 0. So 25 qualifies to be used as our factor. Then now we go on to substitute our 4 where there is X. Our 4 does not give us the 0. Therefore, you go on to say X is not equals to a 4. Then you'll get a mark for this conclusion, because if you just leave your answer here, you are saying when I substitute X on my equation, I'll get a 0. But when you substitute 4 on your equation, you get a negative 12, which is not a 0. Therefore, this conclusion will give you a mark. Then yeah, this sum is done.